Let's do another maximum likelihood estimator example. So in this case, X is the number of customers contacted in a given week before the first sale is made. So in this particular case, they give you the random variable X has this probability function of P times 1 minus P to the X minus 1. Notice that this looks like the geometric distribution because we have 1 minus P would be the probability of failure. We're going to have X minus 1 failures before we have a success on trial number X. So P is that probability of a sale on any contact. We're going to have 3 independently selected weeks. There are 7, 9, and 2. And we want to determine what the maximum likelihood estimate is for P based on that sample. It's the only information that we have. This is a pretty good idea. It's a small example, obviously, but it's a pretty good idea of what you try to do when you're doing this estimating. We have a probabilistic model for what's going on. In this case, we're contacting customers and trying to figure out how long it is before those customers actually make a purchase, before we actually get a sale. We have had 3 customers that we've ran for randomly selected weeks here. We noticed that 7, 9, and 2 were the number of customers that were needed to contact before the first sale was made in those weeks. So that's the only information we have to be able to estimate P. So going forward, you can make planning purposes if you've got a good model for the situation that's going on. That's the whole point of doing this stuff. All right. So to that end, we create our we create our likelihood function just like we have before. We take the product of our PDF with each of the values of our random sample plugged in. In this case, we could put in those specific numbers and plug it in, but let's do this in general to see what the maximum likelihood estimator is. This shouldn't be a huge surprise. Again, taking derivatives with products is hard, so we'll take the log to change them into sums. When we take the sum, it changes this product into a sum, changes this product into a sum. We get log of P plus, we can bring the exponent down, X minus 1 log of 1 minus P. Differentiate with respect to P. Derivative of log P is 1 over P. Derivative of log of 1 minus P, we 1 over 1 minus P, but then we have to take the derivative of the inside by the chain rule, so that's where that minus sign out in front comes in. So we have minus X of I minus 1 over 1 minus P. Again, we're trying to maximize this, where we're going to set it equal to 0 and solve for P. Break up your sum over the difference, move things over to the other side. Now let's see what some more algebra here is. We notice that this is a constant as far as I is concerned, so this will be n over P when we add this up. Here we will pull out the 1 over 1 minus P because it's a constant. Do a little bit of cross-multiplying ideas here, right? And then break up this sum on the right-hand side. When we do that, we get P times the sum of the X of I's minus, well, P times the sum of 1. Well, if I add up 1 n times, I'm just going to get n. Here we just distributed the n to both pieces, so that's why we get n times n, or excuse me, n minus n times P. It was a little weird to get there algebraically, but notice that we have minus np on both sides. So those are just going to cancel out. So if you solve for p, you get n over the sum of the X of I's. And if you look at this just a little bit more closely, we notice that that is the reciprocal of the sample mean. P is 1 over the sample mean in this case. Or your sample mean, or the mean, is 1 over P. So again, this is really one of the reasons why I wanted to go through this particular example without just plugging in the numbers for those 3 particular values. When we calculate the maximum likelihood estimator for the geometric, it becomes the mean as well. The mean is used in that. It's going to be 1 over the mean in this case because the mean of the distribution is 1 over P. In general, we can check that we really do get the that we really will get negative for this value. I'm not going to go through that. So the maximum likelihood estimator, like I just said, is P hat is 1 over the sample mean. So this allows us to answer the question. Remember, the question was based on the sample of 7, 9, and 2. What would be your best estimate, your best guess, your maximum likelihood estimator for P? Well, the sample mean is 6. It's not too hard to figure that out. So your P hat, your maximum likelihood estimator in this case, will be 1/6.